Hi, I'm Shannon Grady, exercise physiologist. Welcome to Lactate 2.0. If you're ready to leave guesswork behind and train with science that actually works, you're in the right place. Today's topic: bioenergetic power scores and a real-world rowing athlete's progression. A traditional lactate curve chart relies on the effort when the temperature or lactate starts climbing sharply around the 4 millimoles mark. From there, many coaches then try to push the curve right by doing lots of steady state rows and threshold pace, hoping the athlete can hold higher speeds before lactate overheats the system. The problem: this single gauge view doesn't tell you whether the engine has enough total horsepower from start to finish across the aerobic and anaerobic systems. If the cooling system, lactate shuttling and clearance, or if fuel delivery, glycogen availability, is weak. Or why the athlete might be fast in the first 500 meters but fade dramatically, or hold steady pace but lack a strong finish. The result of reliance training focused on pushing the lactate curve: many rowers end up overloaded in one area of their physiology and underdeveloped in other areas, resulting in performance stagnation and declines, classic symptoms of traditional threshold-focused training. Using bioenergetic power score charts equals having the full telemetry dashboard used by top Formula One or IndyCar teams, real-time horsepower output across every RPM range, torque curves, subsystem efficiency readouts, fuel flow rates, and a composite overall power score for the entire propulsion system. Bioenergetic power scores quantify the athlete's energy efficiency across 8 distinct lactate systems, from highly aerobic through highly anaerobic. Each system gets its own power score based on an athlete's physiological profile testing data. Coaches and athletes can instantly see which gears or systems have strong power output, which systems are weak or unavailable, creating deficits. Exact training needed for specific performance goals, such as a sub 6 minute for 2,000 meters. Bioenergetic power scores lets coaches prescribe precise training to address individual physiological and performance needs, rather than generic models or threshold-based training. Let's examine a national team rower's bioenergetic power scores progression. This athlete's initial bioenergetic power score chart showed a typical traditional rower profile: decent power in the lower to mid aerobic systems, but significant limitations in higher aerobic and anaerobic systems. His bioenergetic power scores explained why he could hold steady state pace, but lacked the power for strong starts, surges, or finishing kicks required at the international level. After implementing system-based training guided by frequent physiological profile testing and bioenergetic power score tracking, his physiological range increased by 50%. His bioenergetic availability increased by 38%. His 2,000-meter rowing performance improved by 17 seconds, while already being at an elite level. The bioenergetic power score charts made this visible at a glance. Instead of guessing he needs more threshold work, precisely which systems needed bridging or focus, training became efficient and individualized rather than volume or threshold heavy. Bioenergetic power scores charts give coaches and athletes the complete engineering telemetry of the human engine. Bioenergetic power scores charts quantify human power, not just lactate accumulation, reveal balance across systems, and allow precise tuning for predictable performance gains. Bottom line: the traditional lactate curve is like navigating a 2,000-meter race with just a speedometer and one warning light, flying partially blind. Stay tuned for more videos on Lactate 2.0. It's time to revolutionize human performance. If you enjoyed this content, please like, share, and subscribe to my channel.